A magnetic circuit is a closed path or loop that contains a magnetic material and is used to guide and control the flow of magnetic flux. Similar to an electrical circuit, which allows the flow of electric current, a magnetic circuit facilitates the flow of magnetic flux. Magnetic circuits are an essential concept in understanding and designing various electrical devices, such as transformers, inductors, and electric motors. In a magnetic circuit, the flow of magnetic flux is analogous to the flow of electric current in an electrical circuit. The magnetic flux is generated by a source, such as a permanent magnet or an electric current passing through a coil. The magnetic circuit provides a path of low reluctance, opposition to magnetic flux, for the flux lines to follow. Key components of a magnetic circuit. 1. Magnetic core. The magnetic core is the central element of a magnetic circuit. It is typically made of ferromagnetic materials such as iron, nickel, or cobalt, which have high magnetic permeability. The core's purpose is to concentrate and guide the magnetic flux, maximizing its strength and efficiency. 2. Windings. The windings consist of coils of wire wound around the magnetic core. When an electric current passes through the windings, it generates a magnetic field. The windings can be either primary, input, or secondary, output, in devices like transformers. 3. Air gap. An air gap is a non-magnetic region, intentionally introduced into the magnetic circuit. It can be a physical gap or an insulating material inserted between the core's magnetic surfaces. The air gap helps control the magnetic flux, and is commonly used in devices like electromagnets and electric motors. 4. Reluctance. Reluctance is the measure of opposition to magnetic flux in a magnetic circuit. The magnetic materials used in the circuit, such as the core and air gap, have different reluctances. The goal is to minimize reluctance in the desired path of magnetic flux to maximize the efficiency of the magnetic circuit. 5. Magnetic flux. Magnetic flux is the measure of the total magnetic field passing through a given area. It represents the number of magnetic field lines crossing a surface. In a magnetic circuit, the magnetic flux flows from the magnetic source, through the core and windings, and returns to the source, completing the loop. Applications of magnetic circuits. 1. Transformers. Magnetic circuits are extensively used in transformers to transfer electrical energy between different voltage levels. The primary and secondary windings are wound around a magnetic core, which allows efficient transfer of magnetic flux and, consequently, electrical energy. 2. Inductors. Inductors utilize magnetic circuits to store and release energy in the form of magnetic fields. The core and windings in an inductor control the rate of change of current, allowing the device to store energy when the current increases and release it when the current decreases. 3. Electric motors. Magnetic circuits play a vital role in electric motors, converting electrical energy into mechanical energy. The interaction between the magnetic field produced by the windings and the magnetic field of the permanent magnets or electromagnets creates rotational motion. 4. Magnetic sensors. Various magnetic sensors, such as Hall effect sensors, rely on magnetic circuits to detect and measure magnetic fields. These sensors utilize the properties of magnetic circuits to generate a measurable electrical output proportional to the strength and direction of the magnetic field. Understanding and analyzing magnetic circuits are essential for designing efficient and reliable electromagnetic devices. By manipulating the core materials, windings, and other parameters, engineers can optimize magnetic circuits for specific applications, ensuring the desired magnetic field characteristics and overall device performance.